Welcome to The Explainer. Have you ever wondered how investigators can take a computer or a smartphone and just pull out all the hidden clues? Well, today, we're going to pull back that curtain on the world of digital forensics. We're going to demystify the whole process step by step.
This entire field is built on one simple but really powerful idea. Over a century ago, a pioneer named Dr. Edmond Locard said that every single interaction leaves something behind. And in our totally connected digital world, that has never been more true.
All right, let's dive in. We're going to start with that foundational principle. Then we'll look at what digital evidence actually is, explore the playbook investigators use, break down every single step, and finally, see how all the findings are presented so someone can make a decision.
So, to really get how every contact leaves a trace in the digital world, we first need to get on the same page about what digital forensics actually means.
Okay, so in a nutshell, digital forensics is a science. Yeah, really. It's not just about finding files on a laptop. It's a super rigorous scientific process for handling digital info in a way that's reliable, repeatable, and can totally hold up under the intense pressure of a courtroom.
Now, let's talk about those traces. What does digital evidence even consist of? It's not as simple as just, looking at a photo or a document on your screen. There's a lot more going on underneath.
I want you to think of digital evidence like a ladder. At the very bottom, the lowest possible rung, you have the bit. That's just a simple on or off signal, a 1 or a 0. Then a file system comes along and organizes all those bits into the files that we actually recognize. And each step up that ladder, file types, data structures, encoding, it's just another layer of interpretation that takes us from raw electricity to actual, meaningful information.
And here is an absolutely crucial point. Not all digital traces are created equal. Some evidence is incredibly fragile. We call it volatile. Think about the data that's in your computer's RAM right now, or your active network connections. Poof, it vanishes the second you pull the plug. But other evidence is persistent. It's stored on hard drives and USB sticks, and it sticks around. Understanding that difference is just critical for any investigator.
So, to handle all of this complex and sometimes really fragile evidence, investigators can't just wing it. No way. They follow a very structured, methodical process, a playbook, if you will, to make sure nothing gets missed and the evidence stays completely pure. Now, there are a few different models for this playbook. A really common one comes from NIST. That's the National Institute of Standards and Technology. It breaks the whole thing down into 4 clear stages: collection, examination, analysis, and reporting. Basically, you gather the stuff, you find the relevant data, you figure out what that data means, and then you present what you found.
But other models are a bit more detailed. For instance, the DFRWS model, which comes from the Digital Forensics Research Workshop, it expands the process out to 7 steps. And it adds these really crucial early stages like identification and preservation, and then it tacks on a final decision phase at the end. But here's what's really interesting. This whole process isn't always a straight line from 1 to 7. An investigator might be in the middle of collecting data, find some brand new clue, and have to jump all the way back to the beginning to identify a whole new source of evidence. It's a really dynamic process that has to adapt to what the evidence is telling you.
So let's break down that more detailed DFRWS model. We're going to walk through it step by step to see exactly what's happening at each stage of an investigation. Okay, it all starts with identification. In this phase, investigators are trying to identify every single potential source of digital evidence. And in today's world, believe me, that list is massive. It's not just computers and phones anymore. We're talking smart speakers, TVs, doorbell cameras, and even the computer systems inside your car.
So once the evidence is identified, the number one priority becomes preservation. This goes right back to that main principle: don't contaminate the scene. If a device is on, they rush to capture that fragile, volatile data before it disappears. If it's off, they use special hardware called write blockers. Think of it like a one-way street for data. It lets an investigator copy everything off a drive without being able to write or change a single bit on the original.
Next up is collection. And this is not a one-size-fits-all kind of step. The approach totally depends on the state of the system. Live forensics is what they use on running machines to capture that volatile data we talked about. Network forensics looks at traffic and what's connected. And post-mortem forensics, well, that's the deep dive into devices that are turned off, digging for stored and even deleted files.
And this brings us to the two main ways of actually grabbing the data. A physical acquisition is a perfect bit-for-bit copy of the entire device. It's so important because it captures everything, including deleted files and hidden data. A logical acquisition is more like just copying and pasting the files you can see. It's faster, sure, but you risk missing a whole lot of hidden evidence.
So, with all that data collected, we move to examination. A modern hard drive can hold terabytes of data. It's literally impossible to look at everything. So the examiner has to be really strategic. They use these specialized tools to search and filter and carve out the relevant data, all guided by the specific goals of the case. Constant communication with the lead investigators is absolutely key to focusing that search where it matters most. Next is analysis, and this is where the data really starts to tell a story. See, examination is about finding the relevant data, like, say, a photo file. But analysis is about understanding what that data means. It goes deeper, looking at all the metadata embedded within that file, like the GPS coordinates and the exact time and date it was taken.
And just like that, the data gets translated into information. That photo file, with its metadata, now becomes a verifiable fact. This person was at this specific location at this specific time. This is how you connect those digital traces to real-world events. Analysis is all about building those connections.
All right, so after all of this highly technical work is done, it has to be packaged up and presented. The goal here is to translate all these findings into something that can be understood by everybody involved and then used to make a really critical decision.
The presentation phase is all about creating that final report, but this isn't just some tech document. Every single step has to be meticulously documented so another expert could repeat the entire process and get the exact same result. And, so important, the report has to be written for its audience, people like judges, lawyers, or managers who probably don't have a technical background. It has to be clear, it has to be direct, but without sacrificing any accuracy. And this really hits the nail on the head. It gets to the heart of why that clarity is so important. I mean, the most groundbreaking piece of digital evidence you can find is completely worthless if the people making the decisions, the judge and the jury, can't understand what it means or why it matters. The proper use of evidence absolutely depends on its proper explanation. And ultimately, that well-written report forms the basis for the final decision. In a criminal case, this could be the verdict from the court. And in corporate investigation, it might lead to brand new cybersecurity policies to stop another attack. The forensic expert provides the facts. The court or the management, they make the final call based on those facts.
So we've seen how this entire digital world is built on that one core idea. Every single contact leaves a trace. Every website you visit, every photo you take, a trail is constantly being created. Which, leaves us with a final thought. What story is your digital footprint telling about you?